Hi friends, in this video we're going to talk about creating a temperature monitoring and alerting system using Raspberry Pi and a DHT22 temperature and humidity sensor. We're going to create a data pipeline where Raspberry Pi will continuously sample the temperature and humidity data from a DHT22 sensor and store it continuously in a database. We will integrate the database in Grafana so that we can see the temperature in real time in dashboards, and we will also configure alerts over the data so that we can create email alerts when a temperature or humidity crosses a threshold value. In the end, we will create a Grafana dashboard something like this where you can see the temperature in real time actually. I have kept my sensor and the Raspberry Pi system for the last 24 hours, and this is the temperature data being recorded by the Raspberry Pi and DHT22 temperature and humidity sensor. So let's see how we build this data pipeline. We use a DHT22 temperature and humidity sensor. We are using a Raspberry Pi 0W which can use Wi-Fi for internet connectivity and LAN connectivity. We are using a PostgreSQL database server to store the temperature and humidity data in real time, and we are using Grafana for monitoring and alerting over this real-time temperature and humidity data stored in the database. So if you don't know what Raspberry Pi is, it is actually a small computer running Linux on it. It has also GPIO pins so that you can control the pins or read the data from the pins from the operating system. And Raspberry Pi 0W can be connected to a Wi-Fi network. This makes Raspberry Pi 0W ideal for IoT projects. You can see I already created a playlist on Raspberry Pi, and I will leave the link of this playlist in the description. Refer this playlist if you want to know what Raspberry Pi is or if you want to do some small projects on Raspberry Pi. Alright, let's talk about the sensor we used. The sensor is DHT22 sensor. So it's actually temperature and humidity sensor, and it has 3 pins. One pin you need to connect to the ground, one pin you need to connect to the 3.3 volts, and the middle pin would give the data of the temperature and humidity. Now you can connect this temperature and humidity sensor to your Raspberry Pi and write a Python code to read the temperature from the sensor. So we're going to connect the VCC pin to the sensor's VCC pin and the ground pin to the sensor's ground pin. And then we can use any one of the GPIO pins to read the data from the sensor. For this example, we are using GPIO 18 pin and we are connecting it to the sensor. So this way, by just using 3 bytes, you can get data from the sensor. So if you connect Raspberry Pi to the DHT22 temperature and humidity sensor, it will look something like this. You need to give the power supply and you need to connect the wires to the sensor. That's all. Now you can deploy this Raspberry Pi and sensor anywhere and push data to the database. Since it's in Wi-Fi, the database should be present in the same Wi-Fi network, or you can expose your database to the internet or send data to the API, something like that. For this example, the database server is actually in the same LAN of the Raspberry Pi. You can also keep your database server in the internet and whitelist the Raspberry Pi's IP to send data to the database server. Alright, after connecting the DHT22 to the Raspberry Pi, how to read the data from the sensor? Let's write a Python code to read the data from the DHT22 sensor. We can read the temperature and humidity from the sensor. Let's try to write the Python code now. Alright, let's take a blank folder and let's try to open this with VS Code. Let's try to create a new file and just name it temperaturesensor.py. Obviously, you need to run this Python code in the Raspberry Pi, but first let's try to write the Python code in our computer and then transfer it to the Raspberry Pi. So first let's try to import the Adafruit DHT library. You need to install this in the Raspberry Pi, but currently let's try to just write the code and then we will copy the code and install the Adafruit DHT Python library. So first import the Adafruit DHT Python library. Mention the sensor type. So the sensor would be Adafruit DHT.DHT22. Let's try to hard code the pin. We are using GPIO 18 pin. So let's try to create a variable called pin equal to 18. And now you can read the temperature and humidity by just calling Adafruit DHT.readRetry the sensor, which is Adafruit DHT.DHT22, and the pin, which is the 18th pin. Now you'll get a tuple in which there will be 2 variables, humidity and temperature. And let's try to print this humidity and temperature so that we can read the temperature and humidity from the sensor. Just by running this code, you should print the temperature and humidity in the console of Raspberry Pi. We got our Python code ready. Let's try to deploy it in the Raspberry Pi. And before running the code, we need to also install the Adafruit DHT Python library. So I've got my Raspberry Pi running and I've connected my DHT22 sensor to the Raspberry Pi and it's in the same LAN of my computer. So let's try to do SSH to the Raspberry Pi and connect it to it. So I'm going to open a command prompt and then I'm going to SSH my Raspberry Pi. So I'm connecting to my Raspberry Pi using the command SSH Raspberry Pi's username the Raspberry Pi's host name, which is awesome pi. You can even use the IP address, which is 192.168.0.70. In my case, I'm using the Raspberry Pi's host name, and it will ask you if you are sure to continue to connect, and say yes, and then you'll be asked a password. Write the password of the Raspberry Pi, and then you're connected to the Raspberry Pi's Linux terminal. Let's try to clear the screen. Let's try to create a file in Raspberry Pi. Let's try to see the existing files. In fact, there's already a file, temperature sensor.py. Let's try to delete that and create another file, and let's try to run our code. So I'm going to write rm temperature sensor.py. Let's try to see. We don't have the temperature sensor.py file now. Now let's try to create a new file, touch tmp sensor.py, and let's try to edit that, nano tmp sensor.py. Now let's try to copy our code. Let's try to Control A, Control C, and Control V here. We got our code here. In fact, it's complaining about the spacing here. Let's try to remove the space. Now let's try to exit, Control X, save Y, enter. Now we got our code. Let's try to preview the code. In fact, cat temperature sensor.py. We got our code here. Let's try to clear the screen. And remember, we need to install the Adafruit DHT Python module also. Let's try to do that now. You just need to write python 3 -m pip install Adafruit DHT. Let's try to click enter. And now the Adafruit DHT Python library is installed. Obviously, to do this, the Raspberry Pi should have the internet connection. Since the Raspberry Pi is in the same Wi-Fi network of my computer, it has downloaded the Python module from the internet. Alright, we have installed the Python module. We have written the code. Let's try to run the Python code now. So I'm going to write python 3 tmp sensor.py. We got the temperature 26.8 degrees centigrade and the humidity 49.3%. Let's try to run this again, and then you will get the temperature and humidity. So we have run the code and we have printed the temperature and humidity. So in the data pipeline, we have completed the proof of concept of reading data from the DHT22 sensor. Now the next thing is we need to create a PostgreSQL database, create a table in that, so that Raspberry Pi can send temperature and humidity data to this PostgreSQL database. So for this purpose, we will create a simple PostgreSQL table which contains the columns temperature, humidity, the timestamp of the temperature and humidity, and then the sensor ID, which is just a simple string which will identify a sensor. Suppose you have a sensor in your server room, in your conference room, or some other place. The rows being pushed by the server room will have the sensor ID of the server room. The rows being pushed from the conference room will have the sensor ID of the conference room. And these are just constraints which will say that ID is the primary key which is auto generated, and this constraint says that the time and the sensor ID combination should be unique. That means a sensor ID should not give two rows at the same timestamp, which is not practical. So we have kept a constraint like this. And then we are just keeping a simple validation check that the sensor ID should not be more than 50 characters. That's all. It's just a simple PostgreSQL table. So we need to run this SQL to create the PostgreSQL table in the PostgreSQL database. So we need to connect to the PostgreSQL database, right? So I've got a PostgreSQL database running, and I'm going to use dbeaver to connect to the PostgreSQL database. So dbeaver is an awesome database administration tool where you can control multiple databases from a single tool. If you don't know about dbeaver, I will leave the link of a video where I have explained dbeaver. You can check out that link to know how to use dbeaver. For now, we're going to create a database connection in the dbeaver. So here I'm going to click on the create new database connection and select the PostgreSQL. And here you need to give the host name, which is localhost or the IP address of your database, and give the name of the database which you are going to connect, and then give the username, password, and the port on which the database is running, and then click finish. So if you successfully connect a working PostgreSQL database to your dbeaver, you can see the entry here. So I've already created a PostgreSQL connection here. Let's double click this, and here in the databases, Postgres, schemas, in the public, in the tables, you can create a table. So to create a table, let's right click on the public schema, SQL editor, new SQL script, and now copy this table creation script and paste this here and run this execute script button. Then a PostgreSQL table would be created in the database. After you run the table creation SQL, you should see a temperature humidity data table here, and it will have the columns as expected: ID, timestamp, temperature, humidity, sensor ID. And when you send data into the table, the data should look something like this: the timestamp, the temperature, humidity, and the sensor ID. ID is an auto incrementing column, so you don't need to insert this separately. And that's it. We have set up a PostgreSQL table where Raspberry Pi can insert the temperature and humidity data. In the blog post, I've also given you a simple SQL script where you can test whether data is being pushed into the table correctly. Just copy this script and run this so that you can insert some dummy values of temperature and humidity into the database table just for testing purpose. Alright, we have set up a PostgreSQL database. Now we need a Python code to push the data into the database. Let's try to create a Python file called temperatureHumidityDB.py, and here we will create a class which will expose a convenient function where you can push the data into the PostgreSQL database. So it's a simple Python class. By the way, we are going to use psychopg2. It's a Python library to interface with the PostgreSQL database. So we're going to create a class called temperatureHumidityDB, and in the constructor we will ask for the host name, port, database name, database username, and the database password. So we're going to take these database parameters in the constructor of the class itself, and then we're going to create a function called insert data where you will input the temperature and humidity values and the sensor ID value. So in the function, we're going to create a psychopg2 connection to the PostgreSQL database, and we're going to create a cursor, and we're going to create a data insertion tuple, and then we're going to run a simple SQL where we're going to insert into the public dot temperature humidity data values, temperature, humidity, and sensor ID. And if there is a conflict, that means if you're sending duplicate rows, the new row will be accommodated and the old row will be overwritten. So this is a simple SQL which we are running to insert the data from the function, the temperature, humidity, and the sensor ID values. After preparing the SQL and the data insertion tuples, we will run the SQL and the data would be inserted into the database. If there is an error, obviously, we will just print there is an error while interacting in PostgreSQL database, and then we will close the connection with the database server. So this is a simple function which we have created where we will input the temperature, humidity, and the sensor ID values, and this function will insert data into the PostgreSQL database. So alright, in the data pipeline, we have created a function for the Raspberry Pi to insert data into the PostgreSQL database. Just like we created a convenient function to push the data into the database, let's try to create a convenient function to fetch the data from the DHT22 temperature and humidity sensor. Let's try to create a new Python file. I'll just name it temperatureHumiditySensor.py. So here we're going to import a Adafruit DHT Python module because we need to read the sensor, and we're going to create a class called temperatureHumiditySensor, and here in the constructor we're going to ask for the pin in which the sensor is connected. In our case, we would initialize the pin with 18, and then we will define a function called getTemperatureAndHumidity, and in that function we will just write adafruitdht.read the sensor and the pin, and if you get the data, you're going to return a dictionary which will contain the temperature and humidity values. So we have just created a convenient function to read the temperature from the sensor. So now we have created a convenience function for inserting the data, a convenience function for fetching the data. So let's try to create a simple Python script which fetches the data and pushes the data into the database. So let's try to create a main Python script. I'll just name it index.py, and it's going to import the temperature humidity class from the file we have just created, tmp humidity db, and it's going to import the temperature humidity sensor class from the file which we have just created, temperature humidity sensor.py. Now for our example, let's try to give a sensor ID called S1 because we have only one sensor. In your case, you can have multiple sensors with whatever ID you want. In our case, we are creating a sensor ID called S1, and then let's try to initialize the temperature humidity db class with the PostgreSQL server credentials and configuration. This is the host name, port, the database name, the username, and the database password. So these PostgreSQL database parameters are being used to initialize the temperature humidity db class. And then let's try to initialize the temperature humidity sensor class. We're going to say pin equal to 18 because we have connected the 18th pin of the Raspberry Pi to the sensor. So now we got our instances of temperature humidity db and the sensor. Now we have to just read the sensor data and push it to database. So we're going to write sensor.getTemperatureHumidity. So we'll get a dictionary, the temperature in the tmp key and humidity in the hum key. If you get an error, we'll just print it and exit. And if you don't get an error, you're going to insert the data using the temperature humidity db instance. So the temperature humidity db dot insert data, and it takes three inputs, which is the temperature, humidity, and the sensor ID. So first we have read the temperature and humidity from the sensor, and we are pushing the data into the database. That's all. So now if you run this script in the Raspberry Pi, the instantaneous temperature and humidity data would be inserted into the database. So let's try to copy our three files, temperature humidity db.py, temperature humidity sensor.py, and index.py into the Raspberry Pi, and then run the index.py to see if you can push the sensor data into the database. So here I need to copy 3 files, right? So for this I'm going to use WinSCP. So in the left side, I opened the folder which has the Python files, and in the right side, I'm going to create a new session, connect to my Raspberry Pi. So I'm going to write new site, file protocol would be SFTP, the hostname would be AwesomePi or else 192.168.0.70. The port is 22, the username is raspcpu, and the password is the password of the Raspberry Pi, and then login, click S, and now you have connected to the Raspberry Pi. Just copy these 3 files, index.py, temperature humidity db.py, temperature humidity sensor.py, and just drag them here. Now you got your 3 files. Now I can run this index.py to see whether I can push the data into the database. So now the file is copied. You can just close the WinSCP. I'm already in the SSH connection. Let's try to list the files. You can see our files here. Now let's try to run the index.py actually. So I'm going to write python 3 index.py. You got number of rows inserted equal to 1. Let's try to right click and refresh in the table data, and now you got your data here. So just by running a simple code like this, you're able to push the data from the sensor to the database using Raspberry Pi. But hey, I want to store the temperature and humidity at every 5 minutes or at every 1 minute into the database. So I need to schedule a task to store the data of the sensor in the database periodically. So how can I do that? You can use cron tab. So I'm going to write cron tab -e, that means edit the cron tab file, and here in the cron tab you can see your cron jobs. I've already created a cron job which will run the index.py every minute. So this means run the cron job every minute, and this is the command. The command is python 3 and the path of the index.py file. If you want to run this every 5 minutes, you can just write */5. Now this will run every 5 minutes. Or else if you want to run it every 2 hours, you can write //2. It will run every 2 hours. So this is the cron tab syntax. If you want to know more on how to use this cron tab to create periodic tasks in Raspberry Pi, I've already created a video on that, and I will leave the link of that video in the description. But for now, I am scheduling a cron tab every minute, and it will run this command python 3 index.py. You need to give the full path of the index.py. So I have given the full path of the index.py here. Exit, save the cron tab, and enter. Now even if you log out of Raspberry Pi, the scheduled task will run every minute, and the data would be inserted into the PostgreSQL database every minute. And that's why I'm getting sensor data every minute in my database. So now we have successfully completed this whole section of the data pipeline, where the Raspberry Pi is reading periodically the data from the sensor and pushing it to the database server, which is a PostgreSQL database. Alright, we are viewing the database in dbeaver. But I want to create a graph and monitor the data periodically and create alerts over the data. For that, you can use Grafana. So we're going to integrate the database server in Grafana and create dashboards to view the temperature and humidity data. So if you don't know what Grafana is an awesome data visualization, analytics, and alerting tool where you can use very less code and create very intuitive and advanced visualizations. If you don't know what Grafana is, I've already created a playlist on Grafana, and I will leave the link of that playlist in the description. I've already created a video on how to set up alerts in Grafana, so check out that video if you want to know how to set up alerts in Grafana. Alright, let's try to integrate the PostgreSQL database in our Grafana. So if you go to localhost 3000, which is the Grafana portal, you will get a login screen. Let's try to log into Grafana. Now we are logged into Grafana. In the left menu, go to dashboards, and here you can see the dashboards. Let's try to create a new dashboard. So I'm going to write new dashboard and add visualization, or else you can add panel from here, add visualization, and here you need to select a data source, right? So first let's try to create a data source, and let's go to the left menu, connections, data sources, click on add new data source, click on PostgreSQL, and now write the name of the PostgreSQL database. You can write something like temperature humidity db, and create the host. You need to write the host, which is like localhost 5432. This is the host name and the port name of the PostgreSQL database. The database name, which is Postgres, the username, and the password, and then just click on save and test. So when I click on save and test, I should get the database connection is okay. Now your PostgreSQL database is integrated with Grafana. So I've got a data source called temperature humidity PostgreSQL database. Now let's try to use this data source to create visualizations in Grafana. So I'm going to go to the left menu, dashboards, add a new dashboard from here, add new visualization, and select the data source, which is the temperature humidity dB. Now let's try to query the data from the database. So instead of using this query builder, just scroll down and select code instead of builder and write the code to select the data. The SQL query to select the data would be something like this. Select data time, comma, temperature from the public dot temperature humidity data where sensor ID equal to S1. Remember, we are inserting the rows with the sensor ID S1. So I'm going to write where sensor ID equal to S1. And here I'm going to write and time filter of the time column, which is the data time. This is required because if you don't write this, Grafana will fetch the data for the whole time. But Grafana needs to fetch data for only the time range we select here, right? So for that, this time filter is necessary. Notice that I am aliasing the data time column as time because Grafana requires a column called time. And instead of writing the name as TMP, I have aliased it as sensor1 temperature so that it will be shown something like that here. So let's try to run this query, and now you got a visualization in Grafana where you're showing the temperature of sensor 1. The name is sensor 1 temperature and the x-axis is time. So if I change it from last 6 hours to last 12 hours, I can see the data here. If I change it from last 12 hours to last 15 minutes, even then I can see the data here. Now you can click on this options pane. Let's try to even change the name of the panel title, sensor1 temperature, save. Now you got your sensor1 temperature. You can see last 15 minutes or last 12 hours. So this way you have created a dashboard in Grafana and you can monitor this regularly. Here at the refresh interval, click on this drop down and auto refresh every 1 minute. So every 1 minute your dashboard would be updating. Let's try to save the dashboard actually. Click save. Let's try to even change the name of the dashboard. I'm going to click on the dashboard settings. The title of the dashboard would be something like infra monitoring and click on save dashboard. So we have created a dashboard called infra monitoring and we have created a panel called sensor1 temperature, and let's try to make it last 6 hours. Let's try to save the dashboard, and while saving, save the current time range for as dashboard default, save, and now you have created a simple dashboard where you can see the temperature of the sensor1. Let's try to overlay humidity also. Let's try to click on these 3 dots, edit, and in the query you got a query A. Let's try to collapse this and copy this query. So you got a new query called B, and here instead of TMP column, let's try to plot the HUM, which is a humidity column, and I'm going to write sensor1 humidity, and that's all. Now you got the humidity data. Let's try to run this query. So you got your sensor1 humidity and the sensor1 temperature. The humidity is something like 49 point something and the temperature is 26 point something. And now you got a dashboard where you can see the temperature and humidity. You can even see just the temperature here by clicking on this legend. Alright, now let's try to remove the humidity. Let's try to see temperature only. So I'm going to go to edit again and let's try to remove this query B, save. Again, let's go here, reload. Now you got the temperature. Now let's try to create an alert in Grafana if the temperature crosses a threshold. The alert will send a notification via email to the required recipients. So let's try to create a temperature alert in Grafana. So let's go to the alerting page and here alert rules. I've already created an alert rule. Let's try to delete that alert rule and I'll create the alert rule again. So more, delete. So create a new alert rule. So let's try to name the alert, sensor1 temperature alert. Let's try to define the query. So just like in the dashboard, you need to define the query again. So here instead of the builder mode, I'm going to the code mode, and again I've written the same sensor1 temperature query here. Select data time temperature from the temperature humidity data table where sensor ID equal to S1 and the time filter. And here we are getting the last 10 minutes data. You can even change that using the options, and the time range is now minus 10 minutes to now. That means you'll get the last 10 minutes data. So my strategy is I will check the temperature of the last 10 minutes and I will see the maximum of it, and if the maximum temperature crosses my threshold, I will raise an alert. So for that, I have written a query that fetches the data from the last 10 minutes. Now let's try to use this data to create an alert evaluation condition. Let's try to run the query to see whether the data is present. So I've run the query and I got my data here. And here by default we got an expression to evaluate the temperature. First thing is the reduce expression, where I'm taking the input query. Here the query is aliased as A. So here the input is A and we're getting the last sample. Instead of getting the last sample, you can just get the max sample. So we're getting the maximum temperature in the last 10 minutes. This is the expression B, right? So we have created another expression which takes the inputs as B, and if it's above 0 it will be firing. So let me try to fire if it's above something like 25 degrees. Now let's try to preview. Even then it is firing because the maximum temperature was something above 26. So if I keep the threshold above something like 28 degrees and then preview, it will be normal because the temperature is actually below the threshold, which is 28 degrees. So now I have created my threshold condition for evaluating the alert. Now let's try to set the evaluation behavior. You need to select a folder to store your rule. I've already created a folder called sensor alerts folder. If you want to create a new folder, something like this, you can just type it here and click on enter. A folder will be created. So I'm using the sensor alerts folder. Now select an evaluation group. I don't have an evaluation group, so let's try to create one. So I'm going to create a new evaluation group, and here you need to define at what periodicity you will check the alerts. So I'm going to say every 1 minute or else every 2 minutes I'm going to check for alerts. Let's try to name the evaluation group. So I'm going to write sensor evaluation group. You can write any name here. So here I'm defining that the alerts will be checked every 2 minutes. So click on create. Now you got the alert evaluation behavior, and there's one more important parameter called pending period. So you can write it as per your requirement. Suppose you want the temperature to be continuously above the threshold for at least 10 minutes, you can write 10 minutes. That means the alert will be fired if the threshold is crossed continuously for 10 minutes. For our example, let's make it simple and write 0 minutes. That means even if once the temperature crosses the threshold, we will get an alert. Now the next section would be annotations. You can just write a description here. Sensor temperature is high. And then another important point here is linking the dashboard and a panel. You are creating an alert, but you can overlay this alert over a panel. Remember, we have created a dashboard panel. Let's try to link that to this alert. So I'm going to say link dashboard and panel. Our dashboard was infra monitoring. So click on the info monitoring dashboard, and the panel was sensor 1 temperature, right? So click on this panel and click confirm. Now this alert would be displayed as an overlay on this panel. And the last thing is the notifications. To configure notification, that means to connect an email to this alert, you need to give some labels to this. So labels are key value pairs. Let's try to create a label, something called team. Click on enter, and the value would be something like infra. So the logic is something like I'm adding an infra team label here. So we are going to create a notification policy which sends all alerts having the team equal to infra key value pair. So to create a notification policy, we are creating the labels in this alert rule. And that's all. Now let's try to save the rule and exit. So again, go to the alert rules. Here in the sensor alerts folder, you can see sensor 1 temperature alert. The next evaluation is within 2 minutes because we have set the evaluation behavior as every 2 minutes. Now the sensor alert will be evaluated every 2 minutes. Now for testing purpose or maintenance purpose, if you want to pause this alert, click on edit, and here in the evaluation behavior, you can click pause evaluation and then save the rule and exit. And now the alert is paused. The alert will no longer be evaluated. So we have paused the alert for now. Alright, we have created an alert rule. Let's try to create an email contact point because we need to send email to a person, right? So click on contact point. I've already created a contact point called infra team email. Let's try to delete this contact point. Alright, we need to delete it from the notification policy first. Let's try to go to the notification policy, delete my notification policy. Let's try to go to the contact point and delete this contact point. Now let's try to create a new contact point which would be an email. So the integration is email. The name of the contact point is infra team email. Now you can mention the email address of the recipient. So the email would be something like infraperson@gmail.com or whatever. So this would be the email address of the person to whom you want to send the alert. You can even give multiple emails. That means you can give something like infraperson@gmail, infraperson2@gmail.com, and so on. Just write a semicolon and you can write multiple email addresses, and email will be sent to multiple people if the alert crosses the threshold. And in the email settings, you can send a single email to all the emails, and that's it. You can just click on the test, and a test email would be sent to the recipients. Let's try to click on the test, send test notification, and the test alert was sent. Now for Grafana to be able to send emails, you need to configure the SMTP settings of Grafana. Otherwise, Grafana can't send emails. So how can you configure the SMTP settings of Grafana? So since Grafana is installed in my computer, I'm going to go to C, Program Files, Grafana Labs, Grafana Conf, and there's a file called defaults.ini. You can open it with Notepad or VS Code. So I'm going to open it with VS Code. Now let's try to search for a section called SMTP, and here you got the SMTP section. I'm using a Gmail to send the alerts. So the host would be smtp.gmail.com:587. Make the enable as true. Use the Gmail address, the app password of the Gmail, and these settings. You can even set the name here. You can write something like the company's IT team or whatever. For now, I got the sender name as Grafana. So the password used here in the SMTP settings is not the Gmail password. You need to create an app password and use it here. So if you don't know how to set a Gmail app password and use it in Grafana alerts, I've already created a video on setting up alerts in Grafana. Refer that video. Alright, we have set the SMTP settings for sending the Grafana alerts. Now Grafana can send emails for alerts. We have created a contact point called infra team email. Let's try to save the contact point. Now let's try to create a notification policy which will connect the alert rule with the contact point. So here in the notification policies, click on the new nested policy and use the label which you have used. So the team equal to infra. So any alert rule which has this label team equal to infra will be applicable for this notification policy. So we have already created an alert rule with team equal to infra. So our alert rule will use this notification policy. And we're going to choose the contact point as the infra team email which you have just created and just save the policy. In fact, we can go to our alert rules, click on our alert rules, edit, and here at the bottom, we can just preview routing, and then we can confirm that we are using a notification policy where team equal to infra is being used, and the email would be delivered to infra team email contact point. So now we have configured an alert rule, created a contact point to send email, and we have created a notification policy to connect the alert rule with the contact point. And remember, in the alert rule, in the fourth section, we have even linked our dashboard panel. So let's try to go to the home, click on the dashboards and open our infra monitoring dashboard. You can see the alerts are already overlaid. Since the temperature did not cross the threshold of 30 degrees, the alert state is okay here. You can see the alert state here, and you can even hover over the annotation to see the alert state, which is okay. Now let's try to intentionally make the threshold very less so that you will get an alert. Now let's go to the alerting section, alert rules, expand the sense alert folder, edit the alert rule. First of all, let's try to resume the alert. So in the alert evaluation behavior, let's try to unpause the alert. That means the alert will become active again. And in the alert evaluation definition, in the expression, let's try to change the threshold from 28 to 25, and let's try to save the rule and exit. Let's try to expand the alert rules. Here this is the alert rule, and within 2 minutes the alert rule will be evaluated. And since the temperature is obviously above 25, you should get an alert, and you should also get an email. Let's try to go to the dashboard. This is our infra monitoring dashboard. Let's wait for 2 minutes. And now, since our temperature has crossed the threshold of 25 degrees, you can see an alert annotation here. Let's try to see if we have sent an email. So this is the Gmail which Grafana was using, and you can see in the sent mail that a mail has been sent to the infra person and infra person2@gmail.com, and the mail contains that sensor temperature is high and the value is 26.9 degrees. So we have successfully sent a notification where the temperature has crossed a threshold. Again, let's try to change the threshold to something like 28 degrees so that again the alert state would be normal. So let's go to alerting rules again, alert rules, expand the folder, edit the alert rule, and in the definition, let's try to change the threshold to something like 29 degrees, preview, the condition is normal, save rule and exit. And let's go to our dashboard again. Again, the state has changed to okay. So this way, using Grafana, we are able to monitor and create alerts on the temperature data of the sensor. So using DHT22, Raspberry Pi, a PostgreSQL database server, Grafana, we are able to successfully create a temperature monitoring and alerting system. You can use any database server. For this example, I've used a PostgreSQL database. In your example, you can use whatever like MySQL, Elasticsearch, or whatever. You can see I've created a blog post on Raspberry Pi based temperature monitoring and alerting system. I've given you the images, notes, source code so that you can copy paste and implement in your own system. I've also given you the links to some useful resources so that you can do further reading. So please check out the link of this blog post in the description of this video. Hope you like this video, guys. Thank you for watching. Peace.